whenever we measure a number, that number comes with a certain uncertainty, right? So if we were to report that number with too many digits, then some of those digits would not be meaningful because we have a lot of error and uncertainty in those numbers. And this is really kind of the central premise of the idea of significant digits. So oftentimes you'll see me abbreviate this sig figs. So significant figures or significant digits. So for example, if I were to measure the mass of something and I were to find that this object had a mass of 1000.024 grams. Okay, so this is the number that my instrument reported to me. But if I know for sure that the instrument can only measure out with certainty to this digit, then it would be silly to report all three of these digits, because if there's uncertainty in this place, then these values have essentially no meaning because there's too much error here. So again, this is kind of the idea of significant digits. Whenever we measure a number, we have to be conscious of what values actually have significance. Okay, and as you move through other science classes, you'll be able to practice this in the actual laboratory. But for now, what's really important for us to do is to be able to look at a number and figure out how many significant digits a number has, because being able to identify how many significant digits exist are important in propagating significant digits through calculations. Okay, so being able to identify sig figs, there's really 4 rules. So our first rule is that non-zeros are always significant. So these are significant. So for example, if I have a number like 1, 2, 3, 4, okay, all 4 of these digits are something other than 0, so they are significant. So this would have 4 sig figs, which I'm abbreviating here as SF, so 4 significant figures, 4 significant digits. Our second rule is that leading zeros, so these are zeros that come before any non-zero. So leading zeros are not significant. So for example, if I had a number like 0, 0, 1, 2, 3, 4, then these zeros that are coming out front are not significant. So these 2 zeros are not significant, so this number has 4 sig figs, because all non-zeros are significant. So then this leads us to our third rule. Our third rule tells us that trailing zeros, so these are zeros at the end of a number, so trailing zeros can be significant if there's a decimal place shown. So if there's a decimal point shown, then trailing zeros are significant. So for example, if I have 1, 2, 3, 4, 0, 0, then these 2 zeros are not significant because I don't show a decimal place anywhere. So there's no decimal here, therefore these 2 zeros are not significant. So this has 4 sig figs. If I have a number like 1, 2, 3, 4, 0.0, now both of these zeros are significant because I show the decimal. So this now has 1, 2, 3, 4, 5, 6 significant digits. Okay? If I have a number like 1, 2, 3, 4.000, since I'm showing on my decimal place here, right? So I show my decimal point, therefore all trailing zeros are significant. So I have 3 significant zeros and I have 4 significant non-zeros. So total I have 7 significant figures, significant digits. And finally, rule number 4 is that trapped zeros or confined zeros, these are zeros that are between 2 non-zeros. So confined zeros are always significant. So if I have a number like 1, 0, 2, 3, 4, this 0 is trapped between two non-zeros, so it is significant. So here I have 5 significant figures. If I have something like 1, 0, 2, 0, 3, 0, 4, 0, okay, so my confined zeros are significant, so I have 3 confined zeros. I have 1 trailing 0 without a decimal place, right? So I don't have my decimal point here, so this 0 is not significant. So here I have a total of 1, 2, 3, 4, 5, 6, 7 significant figures. So this number has 7 sig figs. So in summary here, so here I have significant, not significant. So numbers that are always significant are non-zeros. So something that's not a 0 is significant. A confined 0 is always significant. Leading zeros are never significant, and trailing zeros can be significant. So trailing can be significant if you see the decimal. If you don't see a decimal, so trailing zeros are not significant if there's not a decimal place. So if you don't see the decimal point, trailing zeros are not significant.